greenhouse gas measurements in some of our cotton plots, and we do our measurements using a chamber system. So we have a Lycor smart chamber over here sitting on top of a PVC collar like this that's inserted anywhere from about 2 to 5 inches into the soil, and we're going to have our greenhouse gases build up in this chamber, and then it'll flow all the way through this tubing that we have into our infrared analyzer that we have sitting in this cart right here. So those gases pass through one of these lines, go into the gas met. They're exposed to a infrared source, and different gases such as carbon dioxide and nitrous oxide will interact with that source in different ways, and that's how we'll determine which gas is coming through and how much of that gas is coming through. We can measure a large number of gases at one time, so we're measuring all of our main greenhouse gases along with ammonia at the same time. And there's some other measurements that we have to take along with just the greenhouse gas measurements in order to calibrate our equation for calculating how much gas we're getting. So if we'll go back over here to the chamber, one of those things that we measure is soil temperature and soil moisture. So we have a probe sitting here that's attached to our chamber, and that's going to measure soil temperature and soil moisture. We use the ideal gas law to calculate our greenhouse gas flux, and that takes into account temperature, so we have to put our soil temperature into that equation. But soil moisture is also something that can affect greenhouse gas emissions. When the soil's wetter, you're going to have more microbial activity, and that's going to increase your emissions typically. Another thing that can affect greenhouse gas emissions is nutrient content. So if you have fertilizer or manure going down, much like we have in our NIFA project, that's typically also going to increase your greenhouse gas emissions, especially from things like nitrous oxide and methane if you're applying manure. So in this particular pot, we have another collar sitting over here, which is where our fertilizer goes into the is going to be put underneath the ground. So we're measuring differences between where the manure or fertilizer is placed versus where it's not placed, and we have been seeing some differences between our greenhouse gas emissions, specifically with manure. In some of our sites in wetter regions of Texas, we'll see increased nitrous oxide emissions with subsurface manure application, and that's because we're adding our nutrients closer to where the microbes actually are, and we're disturbing the soil a little bit, and just stimulating activity of microbes that produce greenhouse gases.